change, M over the S. Then if your damping factor is within 0 to 1, then you will get this typical response of the second order. So this is a second order transfer function response. Okay, for the damping factor within 0 to 1 and the input as a step change. Okay, then we will get this gap. The one steady state is the one dotted line. So until the dotted line, so it's A, which means the steady state. So here is your steady state, which is your B. So we will need to memorize this A and B. So A is actually the peak, the first peak. Okay, the C will be the second peak. Your overshoot will be, you have to memorize this, which is the A over the B. So this one you need to memorize. Same goes to decay ratio. You need to memorize this decay ratio formula as C over the A. So what is your B? Your B is actually the ultimate value because of the change. Because of the change XS. So this is your B value, ultimate value. Or we can say it is a YT when T goes to infinity. So this is your ultimate value, or sometimes we call it the steady state value. Okay. This formula not given. This one given. Not given. Given. So what is decay ratio? It is a second peak over the first peak. So this is the decay ratio done already here. Okay, then gradient of frequency. So from here, you can link to the period of oscillation. So the full cycle can be like this, or it can be, if you have the second curve, it can be from this point to this point. Just like the example that take means a full cycle. Or from here to here, also a full cycle. So this is your T. 2 pi over omega will be your T set. That's okay, then you can get your W equals to 2 pi per T. Then your frequency is 1 over the T, or T is 1 over the F. Okay, then tau is this natural period of oscillation. Okay, then rise time is the first dot, it achieves steady state. So in this case, this one will be the T rise. So this is the T rise. So the T rise is actually B value. When the time T rise, or I put in Y T equal T rise, the answer will be ultimate value. Okay. Okay, so all this formula given. This one given. Rise time we have to find using the term 21. So the term 21 is the one we have the Laplace table. So where's the Laplace table? Okay, so later I will copy the equation. So this is the Laplace table where you can get from the end of the lecture here. I think I include here. So this is your term 21. This one. So this is when your YT, okay, and you only can get this answer. You get this YT when damping factor is 0 to 1, then you can directly use term 21. Okay, then you can see this phi you have to substitute into this one, and all of this you have to change your calculator to radian. So your calculator should change the mode to radian. So the mode in your calculator can be degree, can be in radian. But for the term 21, you have to change the mode into radian. Okay, so you have to change this one into radian. Okay, so this is a short recap that we have. All this we call as the characteristic of the second order transfer function, which is the response of the second order when you have the change of the axis is a step change. Okay, now we can try the first question where we utilize the formula given as above. So this one, as I mentioned earlier just now, this one has to be equal to 1. So what you need to do is you have to divide the whole thing with 4. So remember to change this equal to 1. So once you change this equal to 1, you should be able to get a new transfer function, a different transfer function. So from here, you will get the answer of equal. So this one is 2.5, then over 1 over 4 s squared plus 1 over 6. So this one is just give the final answer. So this one is 0.25 s squared plus 0.4 s plus 1. Okay, so once you have this already, you can calculate the percent of overshoot. You compare this equation with k over tau square s squared plus 2 damping factor tau s plus 1. So you compare this one, oops, too dark already. So this one, you compare this with tau square. And then your 0.4 with 2 damping factor tau. And the last one is 1, okay? So from here, your tau square, it is 0.25. You can solve your tau equals to 0.5. And then your 2 damping factor tau equals to 0.4. So your damping factor equals to 0.4 divided by 2 tau. So 0.4 divided by 2, your tau is 0.5. So from here, you will get the answer of damping factor 0.4. Okay, so you can explain a bit. It is within 0 to 1. So this one is under damp. So under damp response means you will get the one like the typical graph we have, like this. Then cut in between. So this one will be your A, here will be your B. So they ask for percent overshoot, which means you can use the formula. The formula will be given. You just copy the formula from here. So this one is overshoot. Okay, so the formula is K over the B, which is the overshoot equals to exponential term. Then copy the whole thing. So you'll be having your overshoot equals to A over the B equals to E exponential term pi damping factor over square root of 1 minus damping factor power to 2. Okay, so substitute E negative pi, your damping factor is 0.4, then over square root of 1 minus 0.4 power to 2. Okay, use your calculator, then you should get the answer of 0.2538. When you times 100%, you will get the answer of 25.38%. Okay, so this is how we get the overshoot. Okay. Because of damping factor equals to 0.4, which is within the 0 to 1. So this one, damping factor 0 to 1. And this one, you can use term 21. So you'll be having your ys over the xs equivalent to the question given, where you already changed to the final term equals to 1. So just now you have this. Okay, so you will copy this, and you are given m, magnitude of 4. So m equals to 4. Step change means your xs equals to m over the s equals to 4 over the s. So this is our step change. So from here, you will copy the transfer function of this, and this one equals to 4 over the s. So you're having your ys equivalent to 4 multiplied 2.5 over the s multiplied with this whole thing. Okay, so you can refer this with the direct conversion using the term 21, which is this one. So you copy this equation. You have your Laplace table, so you copy this term 21. This is when your ys equivalent to this. So you can see here is exactly the pattern of k over s, and then you have the tau square s square plus 2 damping factor tau s plus 1. So this is the second order transfer function with a step change of m over the s. So this one, they already multiplied to the other side, which is the 1 over the s. So in this case, you're actually having the other value, which is you having km here. So your question just now having 2.5 multiplied with 4, not 1. So you have to keep this 2.5 multiplied with 4 on the top. Okay, so we will have this solution. So your term 21, the conversion of this will give you yt. So this one is term 21. So you'll be having 2.5 multiplied with the 4. Okay, then you copy the whole thing of this one, and also the 5. Okay, the 5 here, then this whole thing, and change the calculator mode to radian. You refer to your Laplace table. So you're having this whole thing 1 minus 1 over square root of 1 minus damping factor power 2 exponential negative damping factor t over the tau, and then sine bracket, then 1 over damping factor power 2, then this one outside t over the tau plus the phi is up tangent square root of 1 minus damping factor power 2, then over damping factor. Okay, and this is a big bracket. So this is exactly the term 21. Okay, so you need to solve inside all of these, then sine the whole thing, and then 1 minus this whole thing. This one is multiplied. Okay, you already solve your damping factor equals to 0.4, and also your tau equals to 0.5. So you substitute these two into this equation, you get 10, then big bracket 1 minus 1 over square root of 1 minus 0.4 power 2, this one square root, then e negative 0.4, t over the tau is 0.5. Then this one multiply lor. Means later you'll be having 1 minus the whole thing. So if you want to put another bracket here, also fine. So it is 1 minus something. Then sine, then the whole thing here is square root of 1 minus 0.4 power to 2 t over 0.5 plus arctangent, then negative, okay, 1 minus 0.4 power to 2, okay, then divide 0.4. Okay, then you do it, you solve one by one. Okay, like for example, what I solve it here, this one will give me 1.09. This give me 0.8. And I have this one solved. Meaning that you actually multiply 1 over 0.5. So you will get 1.83. Same goes to, I solve this. I divide by 0.4. Then arctangent the whole thing. So this will be the answer of, and then arctangent the whole thing will equivalent to 1.16. So you try to use calculator to solve one by one. So you have the 10 square, the bracket 1 minus 1.09 e negative 0.8 t. Then multiply with sine, then bracket 1.83 t plus this one change to radian. Your calculator must change to radian. Arctangent, you will get the answer 1.16. So this is your YT. Okay. Okay. Your B is ultimate value where you get your t goes to infinity. So this is your YT. You will sub the t equivalent or t goes to infinity. When t goes to infinity, this equation, okay, this equation, you just sub t goes to infinity, you will get the whole thing here 0. Okay, like e power to 0, you get 1. If e power to a bigger value, you get 0. So 1 minus 0 is 1. 1 multiplied with 10 is 10. So the answer is 10. So when t goes to infinity, this is actually your B. So your B is 10. This B is when t goes to infinity. So you already got your YT value at t goes to infinity is 10. Okay, so the question they asked here is rise time. So rise time is here. Rise time is this dot. Go down, t rise. So the YT equals to t rise. The value will be exactly the B. So it is 10. Now you want to calculate what is the time taken to reach the value of 10. Okay, so this is 10. So now solve t rise. So t rise is here. And the YT at t rise is equivalent to B value. And your B is 10 that you have solved. B equals to 10. So from here, the equation you can use from here, the equation of this, the whole thing. You want to solve the t, and this t will be solved. Okay, like for example, you will be having this YT equivalent to 10, right? When t equals to t rise. So this will be 10 equals to 10. Copy the whole thing again. 1.09 e negative 0.8 t, then multiply with sine 1.83 t plus 1.16. Okay. So this one bracket. So this one moved to here will be 10 over the 10. Then this 1 minus will be moved to the front, also 1 minus, left with 1.09 e negative 0.8 t multiplied with sine 1.83 t plus 1.16. Okay, this will give you 1 minus 1, which will give you 0, equivalent to all this. So now you have this multiplication here. So you'll be having 1.09 e negative 0.8 t equivalent to 0. Okay, then sine 1.83 t plus 1.16 equals to 0 because of multiplication. Like a times b equals to 0, you're having a equals to 0, b equals to 0, the idea. Okay, so from here, you solve this. What will be the value of e power to negative multiplied with t, give you a 0? So 1.09 e negative 0.8 t, 0 is when t goes to infinity. So this is when the time you actually got the same value b. So it's a steady state value. So this is when the yt is 10. So it means when t goes to infinity, this yt is 10. So the first t value to get the 10 is infinity, which is correct, accurate, but you don't want this. You want this t rise. So you will solve this, bring down sine 1.83 t plus 1.16 equals to 0. So you have to change this one to something you have learned last time, the trigo. So from here you learn some last time when you get this one, you have 0, then this one is 2 pi, right? And this one is pi. And then you repeat. Here will be what? 3 pi. So, and here will be 4 pi and so on. So you will be getting 0, okay? 0, 0, 0, 0 and 0 when the time is sine n pi, where your n is can be 1, 2, 3, 4, 5, something like that. So it will be sine n pi to give you the answer of 0. Like here is 0. Here is 0. Okay. So this is the sine wave. So you'll be having both sides now having the sine. Okay, then you focus on the first wave where you're having the n equals to 1. Then this equation will be sine 1.83 t plus 1.16 equivalent to sine pi. Okay, you can cancel both sides the sine and finally solve the t equivalent to 1.08. And this t is now the first curve of this. Okay, that's why your n equals to 1. And you already solved this t equals to 1.08, which this t is actually your rise time. And this gap is b equals to 10. So yt is 10 when t equals to t rise. So you resolve this as your rise time. Simple calculation. Just practice one more time, then you will get the answer. Remember to change your calculator to radian. Okay, so 1C. 1C is ultimate value. And ultimate value is when y t goes to infinity. So you already solved this equals to 10. So this is your B value, ultimate value. Okay, maximum value. So we also learn maximum value. Maximum value means like this. You'll be having never mind. So sketch a bit, going up and like this, then cut in between. So here is your B, here is your A. Maximum value is A plus B. Just now you have overshoot equivalent to A over the B, and you use the formula, you already calculate the answer to be 0.2 something. Where's the overshoot? This one. So your overshoot answer over here is 0.2538. A over the B. Overshoot is 0.2538, and you get this answer from the formula here, where you substitute the damping factor and also the only the damping factor you need to calculate the overshoot. So it's 0.2538. So 0.2538. And you know your B is equivalent to 10, where your B is actually ultimate value. When your t goes to infinity, you get your yt equals to 10, where this is your B. Okay, so from here, you'll be getting your A equals to 0.2538 multiplied with the B, and finally, you can solve your A equals to multiply with 10, so it's 2.538. So your maximum value will be finally 2.538 plus 10. Okay, sub into here. So 12.538. So this value, this point, 12.538. And your A value, so at this point, is actually 10 plus 2.538. Okay, no. This one is 10. Here is 10. That's why you get your A answer is 2.538. When you have 12.538 minus 10, this will be the gap, which is the peak of the A. Then you get this 2.538. So you are having this maximum value as 12.538, max value. Okay, and lastly, the 1E, which is the period of oscillation. Using the formula, period of oscillation is given. You just have to copy this one. Okay, so 2 pi tau over square root of 1 minus damping factor power to 2. So this is the period of oscillation. So period oscillation means you'll be having from for a full cycle, for example, from here to here. This is your T. So this is your T. So T, period oscillation, equivalent to 2 pi tau over square root of 1 minus damping factor power to 2. Then you'll be getting this 2 pi, where your tau you already solve 0.5, divided by square root of 1 minus 0.4 power to 2. So this will give you 3.42 S. Means this T is 3.42. And then question 1 done. Okay. Question 2, I do not discuss here. It's an additional example for you to try again for this question 1 with different example. So if you look at the question 2, you have the question 2, you will see the last term also not equals to 1. So you have to divide the whole thing. The question is y over the s over ss equivalent to 10 over 2s squared plus 0.3s plus 0.5. So this term, you have to divide 0.5, divide 0.5, divide 0.5, and don't forget the top also have to divide by 0.5. So it's exactly the same question, similar question, to calculate the ultimate value, overshoot, maximum value, frequency of oscillation, which is the f. So frequency of oscillation, also you can refer to the formula. Okay, frequency of oscillation. So this one, question 2, I will skip. So from here, frequency of oscillation is the f. Where is the f? So I already mentioned here, when you get a t, then you will get 1 over the f, meaning that your f is equivalent to 1 over the t. Okay, so this is the frequency of oscillation. So f is 1 over the t, which is the frequency of oscillation. Okay, so this one, example 2, question 2 is the additional example where you have to divide the whole thing by 0.5 to make this term equivalent to 1, same like the first question. Okay, so proceed. Question 3. So this question 3 is like the one, the graph is given to you. They want you to actually solve y4. So this y4 is in t response. Supposedly it should be t equals to 4. Okay, they want you to find the y value at time equals to 4 using the 2 graphs given here. Okay, so you'll see the keyword given for the first graph is unit step change, meaning that your xs is 1 over the s. Impulse change is ss equals to 1. Follow the table of Laplace transform table. You can refer to the first 2. So unit impulse means 1. Okay, unit step means 1 over the s, means the unit is 1. Okay, when you change to s response, it becomes 1 over the s. But if the unit is 1, when they say it is an impulse, so it is unit impulse, your fs will be 1 for impulse. Okay, so this is the term 1 and term 2. So from here, you are having this unit impulse. This is unit step change. Okay. Okay, now this is the one given to you. You are actually having 2 transfer function, 2 input type, 2 types of input. One is the impulse, unit impulse, and one is the step change. So how you split this equation into 2 types of inputs? So 2 over the s, 2s plus 4 over 4s squared plus 0.8s plus 1. So this is like multiplied 1 time, multiplied 2 times. So you will be having 4s over, the denominator will be the same, so just copy, plus 0.8s plus 1, then plus 8 over the s, then 0. So this one is the same. So 4s power to 2 plus 0.8s plus 1. Okay. Then you focus on this one, the first one. This one, the second one. You split the equation to be ys over equals to 4s over 4s squared plus 0.8s plus 1. So if your axis, you have to identify either it is unit step change or unit impulse. So from here, you'll be having ys over this one, if S, you move to here, right? It will be, if you move to here, you'll be having, so just now we have to cancel the S, right? So let me check. So for S, yeah, you forgot the S here already. So you have the S. Yeah, the S is missing just now because the whole thing multiplied with this, then over this. So the S is missing just now. This one, the S. Okay, so from here, you suppose already cancel the S. Cancel. Cancel, cancel. So it will be just 4 on the top. So this is just like you multiply with 1, right? So you move your excess equals to 1. Then left with 4 over 4s squared plus 0.8 plus 1. Same goes to this one, your ys equals to 8 over, so this one is multiplier. So s, then 4s squared plus 0.8s plus 1. You move this, just imagine here you got 1 here. So you have your 1 over the s, move back to here so that you will get back 1 ys over 1 over the s. Just like you imagine here is your 1, right? You move back over the 1. Then this is your excess. So this will be your impulse, unit impulse, where excess equals to 1. Same goes to this. When you move this 1 over the s to the other side, this is your excess. And this is your unit step change. Then left with 8 over 4s squared plus 0.8s plus 1. Okay, I just move this so that go here, become SS equal to 1, becomes unit impulse. Okay, because SS equal to 1 is unit impulse. Then I move this 1 over the S to the bottom. So my SS here will be unit step change. Because for all the formula, you'll be having ys over ss for transfer function. So you will move this one to here so that you will be having your ss equals to 1 over the s. So this is a unit step change. So in this case, you'll be having the YT, the first graph that you can utilize when the axis is step change. So this one, meaning that if you change to YT, right, you already provided this graph, which is the unit step change already, this one, unit step change already given to you. So this is a unit step change given to you. The YT is given, so you no longer using the Laplace table to convert the YS to YT. The graph is given to you. So this is YT. But now here it is 8 here. So you'll be having the whole thing here is 8 YT. And this one you should use unit, which is this one. You have to use the unit step change for this. And here is the impulse, unit impulse. And you already have 4 here. So your YT will be 4 YT. So now to solve the YT, solve. So I will put YT1 and YT2. So solve YT1, where you need to use unit impulse, which is this curve. So from here, you have the standard equation of tau square s square plus 2 damping factor tau s plus 1 equivalent to 4s squared plus 0.8s plus 1. Both also the same. This one the same, this one the same. They are the same. So you compare with their standard equation for second order, their denominator. So you're able to solve tau square equivalent to So your tau is 2. Then 2 damping factor tau equivalent to 0.8. So damping factor equals to 0.8 divided by 2 tau. 0.8 divided by 2 tau is 2. Then this one is 0.2. Okay, and the first YT is using impulse. So you focus on this curve, you will solve T over the tau, where they ask you to find Y4. So your T is 4. So T over the tau, 4 over tau is 2. So here you have 2. So T over the tau equals to 2. Then you have damping factor here. You have calculated the damping factor as 0.2. So you'll be using 0.2, which is this one. Okay, 0.2. So you go up, touching this line, and then go here. So you roughly will get this tau YT equivalent to tau YT. So based on this, I have to find my answer here. So tau YT is 0.63. So this one will give you 0.63. So this is your tau YT because of this. Okay, so you'll be having your tau YT equivalent to 0.63, YT equivalent to 0.63 over the tau, where your tau is 2. So 0.63 over the 2 is 0.315. So this one here, you'll be getting your YT total equals to 4YT1 plus this 8YT2. So the first YT, so 1, so this one is 1, 0.315. Now you need to solve this YT2, which is using the step change. So from here, step change is using this curve. Okay, this curve. So again, T over the tau is 4 over tau is the same value just now you have calculated because of the same denominator. So here the tau you have calculated as 2, damping factor is 0.2. So tau is 2. So this will give you 2, right? So T over the tau. T is 4 because they asked for T when T equals to 4. That's why they asked Y4. So T equals to 4. Tau equals to 2, so you get 2. Go up. And your damping factor just now you have calculated as 0.2. So 0.2 is this, right? So you will go to the top. So here, then you go here. Here your YT. So your YT is using the graph paper. You will get the answer 1.2. So this is your YT2, 1.2. Okay, your T over the tau equals to 2. Because your T is 4, tau is 2. And your damping factor just now you already solved. Your damping factor is 0.2. That's why you are using this curve. Okay, so you solve the YT2 equals to 1.2. Then you put the value here, 1.2. Then you will get the total value 10.86. Done. Okay, so this is question 3. Then the rest will be the simple one that we actually have approximation method. So the approximation method will be in your test as well. So we'll have few example. I cover 3, 4, 5, 6. Okay, so we do the 3, 4, 5, 6. It's recorded, or yeah, it's recorded. So if you cannot copy the full one, it's okay. You refer to a recording later. You can complete the rest. So the most important one is to understand the concept. Okay, so as usual, you need to submit later the homework. I think I gave some homework for lecture. So that one, example 2 for approximation method, please solve and submit. And also your full solution of tutorial. Combine together, submit to the week 4 homework. Okay, so this one, you will need to copy the equation E negative theta S. The list of appendix, we have 2 equations given. So this is 1 minus theta S. The other one is 1 over 1 plus theta S. So these 2 given. So now they say, okay, use the Taylor series expansion. Okay, meaning that you do not have the half rule. The biggest tau will be your tau already. Like for example, this one will be your tau. And they ask you to derive the first order plus time delay model, which means you'll be having GP, or they use the G. Okay, G. Okay, as a function of S will be KE negative theta S over tau S plus 1. So the tau already solved. If let's say it is Taylor's expansion, so I put here. So A using the Taylor series expansions. Okay. First thing you need to do is expand the equation so that you'll be having these 2. For example, you have K expand multiplied with 1 minus theta S 0.3S. So you will rearrange so that it will look like this and this one. That's why I rearrange this to be 1 minus theta S to fulfill this, so that I can get the answer e power to negative 0.3S. So this one. So multiply with 1 over, arrange the tau 7, 4, 0.4, the biggest one. So in your test, they won't be arranged in order. You have to always remember to arrange the tau from the biggest tau, like 1 plus the biggest tau is 7S, multiplied with 1 over 1 plus second largest tau, and then the third largest tau. Okay, so once you have this already, you already solved your tau here. Your tau is 7, which this one is 7. And whatever you have used for the tau, you cannot use anymore. So you will compare this equation with this to give you e power to negative 0.3s. So this equivalent to e negative 0.3s. And this one will give you e negative 4s. And this one will give you e negative 0.4s. So finally, your g as a function of s, first order plus time delay will be k e negative, then the rest you have to plus together, 0.3 plus 4 plus 0.4. Means you plus all these together, 0.3. When you have e negative 0.3s multiplied with e negative 4s multiplied with e negative 0.4s. So index, right, you will plus all of them together. Okay, like this. Then over, your tau is 7s plus 1. So your final answer will be ke negative. So this will give you 4.7 s over 7s plus 1. So this is Taylor series expansion. The tau will be biggest tau. Okay, then you repeat the same for the same line you have explained. Do the expansion. Now for the second approximation method, which is the GOJover half rule. So this is the B. So from here, erase first. Okay, I give you some time to copy this. Okay, then we are going to use the half rule. So revision first. Half rule means you'll be having the second largest tile contribute to half. The half of the second largest tile will contribute to the biggest tile. Okay, so you copy this. So G equals to KE negative theta S over tau S plus 1. So this tau is, formula is biggest tau plus half of the second largest tau. So we'll be having 7 plus, so this is the second largest tau. So 1 over the 2 multiplied with 4, so 7 plus 2, it is 9. So we'll get this tau equals to 9. Okay, then you cannot use this anymore. It is already used for your tau. And this one will be only left with 1 over 1 plus 2s. Because half already contributed, which is 2. Already contributed to this to have 9 as your time constant. Then you can repeat the same one like the one you have. This one will equivalent to E negative 0.3s. Then this one will equivalent to E negative 2s. And this one will equivalent to E negative 0.4s. So this will KE negative 0.3 plus 2 plus 0.4, then bracket S over 9s plus 1, which I plus this one, and this one together. So this will give you the final answer of KE negative, so 0.7, so 2.7 over 9s plus 1. Okay, then we will try another few more. So question 5 will be having the part A and part B. A will be first order plus time delay, and B will be the second order plus time delay. They use the half rule. Okay, so we move on to the next question. So we have 5 and 6. Okay, we'll finish then finish. It's a quick one. So we'll move to repeat again using the GOJover method. So this one you have to rearrange GS equivalent to K multiplied with, remember to copy E power to negative theta S equivalent to 1 minus theta S equivalent to 1 over 1 plus theta S. So you have to rearrange the equation so that you'll be having 1 minus theta S. Like this one, you have to make sure you do the modification so that you'll be 1 minus theta S. So you have to divide by 2 multiplied by 2, correct? So that you will get 1, 2 divided 2, you get 1. Then this one, 1 divided by 2, you will get 0.5s. So this will give you 1 minus 0.5s, then the whole thing multiplied with 2. Because you need to fulfill the pattern of 1 minus theta s. So how to make this 2 minus s to become 1 minus theta s? You just divide the whole thing with 2 multiplied with 2. So that you will get this whole thing equivalent to 2 multiplied with 1 minus 0.5s. Then you will have the pattern 1 minus theta s, 1 minus theta s. So modification should be done. You'll be having 2 multiplied with 1 minus 0.5s, then E negative 1s. So here you have to do modification. Change a bit. Okay, 1 minus 0.5 e negative 1s. Then over, okay, don't over, you have to make sure you expand the equation. So multiply with 1 over, arrange from the biggest tau. 14, 2, 0.3, oh, okay, 0.04. It is already arranged. So the biggest tau was 1 plus theta s, 14s, multiply with 1 over 1 plus 2s, multiply with 1 over 1 plus 0.3s, multiply with 1 over 1 plus 0.04s. Okay, so once you have this, I will need to use this one later for second time. So I will just copy first. So I need to use for first order and also the second order. Okay, so I'll copy here this one. Okay, so now it is first order plus time delay means first order that time equivalent to ke negative theta s over tau s plus 1, and they ask you to use the half rule. Okay, half rule. Your tau will be biggest tau plus half of the second largest tau. So biggest tau is 14. Second largest tau is 2. So half of it, 2. So you will get 15. So you already solve your your tau equals to 15. And then the one you have used for tau you cannot use. And this one you have to put 1 over 1 plus 1s because half of it, like this one, give you 1, right? So the half of the 2 already used for the tau calculation. So the remaining is only left with 1. So just 2 divided by 2 lah. So then you can compare with this equation. So this front part will give you e negative 0.5s. Originally, you already have e negative 1s on the top. And this one will give you e negative 1s. And this one, e negative 0.3s. And this, e negative 0.04s. So you'll be having k multiplied with 2. So like this one going down, then bottom is tau s plus 1, so 15s plus 1, where your tau is 15. So this is your tau, then e. Then you plus all of this together. Okay, this one, okay, this one, and this one. Then plus all of them together, you will get negative, then 0.5 plus 1 plus 1 plus 0.3 plus 0.04, and then s. So this will give you 2.84. 2.84, correct. So k, so we will normally move the 2 like this, 2k. Okay, e negative 2.84s over 15s plus 1. So this is the first order. For second order, I do it here so you can compare. Second order means ke negative. You'll be having second order theta s. The top will be the same over tau 1s plus 1, tau 2s plus 1. So this one will be the second order that time. So second order time delay, or that time the same thing. Okay. So just now we already so I give you some time to copy again this equation. Now using the half rule, we want to solve the second order plus that time. The tau will be the same idea. It will be first tau, or you can do it here. Tau 1 will be just the biggest tau. So don't touch, you will get 14. Tau 2 will be second largest tau plus 1 over 2 multiplied with third largest tau. So second largest tau is 2. Third largest tau is 0.3. So 1 over the 2 multiplied with 0.3. This will give you the tau 2 equivalent to 2.15. So you already solved your tau 1 equivalent to 14. Tau 2 equivalent to 2.15. Okay, then repeat the same for the rest. So the one you already used for tau cannot include. This one cannot include. This one will left with half. So 1 over 1 plus 0.15s. And then compare all of these with the equation of these two. Sorry. Compare the equation of this one. This will give you E minus 0.5s. And this one, you already originally is there. And this one will give you E negative 0.15s. And this one will give you E negative 0.04s. So this one later plus, 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 plus. So your final answer, this one will be KE negative theta 0.5 plus 1 plus 0.15 plus 0.04. Over, and remember, is a bracket and S. Your tau 1 is the biggest tau, 14s plus 1, and then 2.15s plus 1. Okay, so this is second order. If I ask you to use Taylor's series expansion, then it will be easier. Your biggest tau will be 14. Your tau 2 will be the second largest tau, which is 2. Then the rest you will actually use the same way to calculate the time delay. Whatever you have used for the tau, you have to cancel like this and bring some highlighter during your test as well, like me. If I highlight, then I will see clearly the one I highlighted, I need to plus together to give me my tau. So my tau here is finally 1.69. So KE negative 1.69s over 14s plus 1, then 2.15s plus 1. You'll be having this one in your test. So you try a few times. It's very simple question. It's using the approximation method, mainly based on just these two equations. Okay, Taylor's series expansion, no half rule. If first order, then the tau will be the biggest tau. If second order, you'll be having the tau 1 biggest tau, tau 2 second biggest tau. Only the half rule is a little bit complicated because it will contribute the second largest tau, half of it to the first tau. So I also cover the second order. So you can see from here, you will see the first tau will be just the biggest tau. So we can make a summary there. So this one is the biggest tau. And your tau 2 will be second largest tau plus half of the third largest tau to give you the tau 2. And when you already contribute half of the third largest tau, remember this one, okay? You have to change this into this because you already contribute half. So 0.3, the half is 0.15. So to make it clear, maybe you can just put 0.3 divided by 2 is 0.15. So 0.15 contribute to the tau, then contribute to the time delay. So you have 0.15 here and 0.15 here. The 0.15 contribute to your tau, and 0.15 contribute to your time delay, which is this one. Okay, so this is the second last question. We will try the last one, which is question 6. Using, let's say I use the both Okay, I try to use both Taylor and also the GOJover method. Okay, so now do this one and then the end of tutorial of today. So this one, they want KE negative theta S, second order. So you'll be having tau 1S plus 1, tau 2S plus 1. So I will be having two approximation method for you to do as a revision. So one is Taylor series expansion, and the other one is GOJover half rule. Okay, so as usual, you'll be having this one expand, copy these two equations from the list of equation, and then make the transfer function given to you to look like these two, so that you can do the time delay later. So you'll be having 5 multiplied with and arrange like this one, tau 10, 4, this is 1, this one is 0 0.2. So if let's say I give you 1 over 3 plus 5s, what you need to do is divide by 3. Divide by 3, correct? And then you have to multiply by 1 over 3 here, so that it will go back to the original 1 over 3 plus 5s, correct? So you'll be having 1 over 3 multiplied with 1 plus 5 over 3s. Example, like this one, I do not give you some challenging, but I do discuss in the tutorial, what if this is the one given? If 1 over 3 plus 5s, then what you need to do, you have to do this one and finally get this one. So some of you careless, you put the 3 on the top. Actually, the 3 is at the bottom. So you have the 3 over the 3, multiply here 3, get back the answer. This one will be exactly the answer of this. Okay. Oh, correct. Yes. So just like I bracket here lah. So 1 over the 3 is actually at the bottom, means 3 multiplied with 3 over the 3. 3 multiplied with 5 over the 3. You divide by 3, multiply by 3 at the bottom. So if this is the one given in your test and final, you should be able to solve. It's already discussed in the tutorial. Okay, so this one, 1. Okay. Correct, huh? So if I have 3 over 5s, I have to divide with 3, divide with 3, multiply by 3, correct? So here is 3 plus 5s. So if you confuse, then you can do again your simple maths. 3 is outside. We factorize the 1 over 3 here. You should be able to get back the original answer, right? Like this. So the same thing. So you should do multiplication. You will be having 1 over the 3 here at the bottom. Okay, so this question, they give you everything that you can refer, like 1 over 1 plus theta s without any modification. So this is when, what if it is given something like this, meaning that one of the term at the bottom, I continue with 5s plus 3. Something like this. Then you'll be having this one, modification to be this, if this is the question given. So this one is if. Okay, then you will be having a little bit of modification, so that you'll be having the pattern of 1 plus theta s here. Okay, so this question is a simpler one. So we do as usual 1 over 1 plus 10s, 1 over 1 plus 4s, 1 over 1 plus 1s, 1 over 1 plus 0 0.2s. Taylor series expansion means we will have the answer of this. So now we have to solve the tau 1. The tau 1 is the biggest tau, 10. This one will be the tau. So tau 1 and tau 2 already solved. It's very simple for Taylor series expansion. It will follow the first biggest tau and the second largest tau. So you already solved your tau 1 is 10, tau 2 is 4. Okay. And then this one you already use for your time delay. And sorry, you already use for the tau, don't use. This one also don't use. So left with this E negative 1s, E negative 0.2s. So you'll be having KE negative plus this one and this one. So 1 plus 0.2s over 10s plus 1, 4s plus 1. Done. Taylor series expansion. If GOJover, then you repeat the same. GS equivalent to 5 multiplied with 1 over 1 plus 10s, 1 over 1 plus 4s, 1 over 1 plus 1s, 1 over 1 plus 0.2s. So from here, tau 1 is biggest tau, which is 10. Tau 2 is second largest tau plus half of the third largest tau. So second largest tau is 4. And then 1 over 2, third largest tau is 1. So this one will give you 0.5. So 4.5. And then whatever you have used for tau, you cannot include. You cannot include. But this one will still have the remaining half. So 1 over 1 plus 1 over 2 multiplied 1 to give you some ideas. Half of this one is actually 0.5. So it will give you 1 over 1 plus 0.5s. So from here, you will having this equivalent to E negative 0.5s and this one equivalent to E negative 0.2s. Then you highlight this one and this one. So final answer is KE negative 0.5, 0.2, so it's a plus. Then S over biggest 10, S plus 1, and then 4.5S plus 1. So don't forget you have the 5 over here. So it is not K in this question, it is 5. This one is 5. So 5E negative 0.7S over 10S plus 1, 4.5S plus 1. Okay, so that's all for today. Stop recording. So next week, we will having Simulink, not just the hands-on for the Simulink, we will also do the revision for the test as well. So we will repeat the modeling part that we use the transfer function method to solve using manual calculation. And then we will be solving using the simulation, the Simulink. So you have to start to do your revision already. Now already week 4, we already cover all the tutorial 1 until tutorial 4. And your test will covering from tutorial 1 until the tutorial 6. We do not have the tutorial 6. Means your simulation, lecture 5 and 6 will be also in your test. You can start your revision already. You already done 4 tutorials. Okay, so we have Taylor's expansion today and also the GOJover method today, as well as you have the second order response, and you have learned the nature of response where damping factor equals to 1, smaller than 1, larger than 1. And in the tutorial, I only cover the term 21 for your damping factor within the region 0 to 1. But in the lecture slide, I did discuss when the damping factor equals to 1, you have to solve using partial fraction. And I have covered the situation for tau 1 equals to tau 2 or tau 1 not equals to tau 2. And also the equation will be given for your YT when your damping factor is larger than 1. Okay, I know today quite a lot for you to digest. Take some time. You have another 6 hours for the revision per week. So 4 hours will be used for your lecture and tutorial. The other 6 hours, you should squeeze your time to do the revision for all the modules, another 6 hours. Okay, and complete all the tutorials of today, plus the 2 examples in the lecture slides, and submit to my times. Okay, that's all for tonight. Thank you very much and bye-bye.